So now in this next example, we want all solutions on the interval from 0 to 2 pi. Now, if we tried to get this equal to 0, there's nothing that would really happen that we could go further with. So this is a special case where you need to square both sides so that way you can start creating some trig identities to work with. So if that's the case, I would have sine x plus 1 squared equals cosine x squared. So sine x plus 1 squared, remember that means we're going to write this twice and FOIL it, and this side becomes cosine squared x. Now, if I FOIL this out, I have sine squared x plus 2 sine x plus 1 equals cosine squared x. So now we're getting things a little better because I can use this cosine squared x and a Pythagorean trig identity to change everything to be in terms of sine. So this becomes sine squared x plus 2 sine x plus 1 equals, and we know our Pythagorean trig identity, sine squared x plus cosine squared x equals 1, tells us that cosine squared x is 1 minus sine squared x. Now my equation is totally in terms of sine. So I'm going to get it equal to 0. My right side equal to 0 by adding sine squared x and subtracting 1. So I have 2 sine squared x plus 2 sine x equals 0. So now I see my GCF on this side is 2 sine x. If I factor this out, I have 2 sine x times sine x plus 1 equals 0. So 0 product property tells us that 2 sine x equals 0, or sine x plus 1 equals 0. So I can solve both of these on the right here. I'm going to leave a little gap underneath this line, and you'll see why in a second. So I have 2 sine x equals 0. So that means that sine x equals 0. So remember, we're focusing on the interval here, including 0, right? But not including 2 pi. So I want everything including 0 up to not including 2 pi, where sine is 0. Now, whether you use your unit circle or you envision the curve of sine in your head, we know that sine x is equal to 0 at 0 and pi. And actually, you could say 2 pi, but remember, we're not including 2 pi, so that's not part of our answer. So now we also need to check sine x plus 1 equals 0. So when does sine x equal negative 1? Now remember, that is y in our unit circle. And we know that sine equals negative 1 when x is 3 pi over 2. Now, here is something we must keep in mind for this problem. And make a note of this here. Since we squared both sides and changed the equation, we must check for extraneous solutions. So the equation that we solved is this one, right? That is not the same as this original equation. So since we changed the equation, we have to plug these 3 answers in to our original problem to see if they work out. So let's check our purple answers in our original equation. Does sine of 0 plus 1 equal cosine of 0? Well, that is 0 plus 1 equals 1. So yes, that is a solution. Now I have to check pi. Does sine of pi plus 1 equal cosine of pi? Well, sine of pi is 0 plus 1, but cosine of pi is negative 1. 1 does not equal negative 1. So therefore, pi is extraneous. So we can cancel out pi now as a solution. So let's check my third answer in green. Does sine of 3 pi over 2 plus 1 equal cosine of 3 pi over 2? So sine of 3 pi over 2 is negative 1, and cosine of 3 pi over 2 is 0. 0 equals 0, yes. So that means our only solutions, not extraneous, are 0 and 3 pi over 2. So note, we only have to do this when we change the equation by squaring both sides.